the first thing I'd like to teach you is that when we have the inverse of sine A equals to B, we just switch the A and B, and that becomes sine B equals to A. So we can get rid of the inverse of sine just by switching these two values there. Now this sine, -1 here, is the notation for the inverse of sine. Okay, so I want you to think about this as a notation for inverse sine. What I don't want you to think about it as is sine to the power of -1. So it's not that, it's inverse sine, a notation for that. So how this works, let's have a look. So if we have inverse sine 1 equals to x, to get rid of that inverse, I just need to change the 1 and x. So you can see the 1 has become x there, and the x has become 1. And now I just need to consider sine of what equals to 1. And that's going to be sine of pi on 2, isn't it? Or 90 degrees. So therefore x equals to pi on 2. Now before you go further in this module, the prerequisite is to know all your exact values off by heart. You're going to find this extremely difficult if you don't know that. So if you don't know that, I'd like you to go back and look at that table and memorize that completely before we keep going. Okay, so the second rule I'd like to teach you about your sine values is that the inverse sine of -A equals to exactly the same as if we just took that negative outside. So the negative within the bracket can be brought out. So for example here, if we have inverse sine of -1, we can bring that negative out, so it becomes negative inverse sine of 1. And remember, we have just worked out that the inverse sine 1 equals 2 pi on 2, so that negative just gets brought out to the front of that. Can you see that? Great. So let's use these two rules that we have just learnt in some questions now. So in question 1, I want you to evaluate the inverse sine of 1 on square root 2 in terms of pi. So the first thing we do is let inverse sine 1 on square root 2 equal to x, because we're working out what x equals to, aren't we? So to get rid of that inverse, we just need to switch the x over here and the 1 on square root 2 to the other side of the equals, yeah? And now we just need to consider, well, sine of what equals to 1 on square root 2? That's going to be exactly pi on 4, isn't it? Or 45 degrees. So x equals to pi on 4 there. So therefore we can write that the inverse of sine 1 on square root 2 equals to pi on 4. So because we've let this equals to x, we want to change x back to the original question when we answer it in full. Okay, question 2 now. Let's evaluate inverse sine 1 in terms of pi. So we will let inverse sine 1 equal to x, switch the x and the 1, and that becomes sine x equals to 1, and we think to ourselves, sine of what equals to 1, and that's pi on 2. Change your x back to your inverse sine, and we know that equals to pi on 2 like that. Great. So here we want to evaluate inverse sine of half. So once again, what we'd like to do is make it equal to x, change the x and equals to half, and that's going to be pi on 6, isn't it? So our final answer is going to be that inverse sine of half equals to pi on 6. Okay, we want to evaluate inverse sine of -1, and that's in terms of pi, using this rule here. So the question has been kind to us. It's reminded us that when we have the inverse sine of a negative value, that negative can be brought out the front and the value itself becomes positive, as you can see here. So we have inverse sine -1 equals to negative sine inverse of 1. So we just brought out the negative. And now we know that inverse sine 1 equals to pi on 2. So that just becomes negative pi on 2. Can you see that? So the first thing we like to do, bring out the negative, and then we like to evaluate it. So here we want to evaluate inverse sine of negative 1 on square root 2. So first thing is bring out the negative, yeah? And then we consider this, which we have worked out previously, haven't we? And that was pi and 4. So that negative just comes out the front like that.